Hi, my name is Shehroz Ahmed, and in this video we are going to discuss a topic of statistics. And the topic that we have to discuss is linear regression. So in order to understand the linear regression, first of all we have to go through the scatter plots. So let's suppose we see some graphs, like some plots. So they are the scatter plots. So let me just draw a scatter plot over here. So let's suppose this is the y-axis, over here we have the x-axis, and there are some point that we have marked against for y against x. So these are some of the points on the graph. So hence it has formed a scatter plot. Let me just draw another scatter plot. This is the y-axis, over here we have the x-axis, and there are some points like this. Now you see over here, these points, they are not on a straight line. Also you can see in this graph, these points are not on a straight line. So if we have to estimate the value of y with respect to x, then we cannot judge the value exactly. So for that purpose, in order to estimate the value of y from x, we can take the help of this graph, and we can say that up to how much percent this graph is authentic. But first of all we have to draw the line of best fit. So the line of best fit is the line that will pass through the maximum points through the graph, and we can use that line of best fit to estimate the value of y with respect to x. So for this graph, my line of best fit will something like this. Now we can use this line of best fit to get the value of y against x. So let's suppose x, the values of x are here, 1 2 3 4, values of y are here, 1 2 3. So let's suppose we have to find out the value of y with respect to x, that is 2. So it will be, I will go into the graph and we will see the value of y will be equal to 2. Now this is just the estimate. Now in order to check how much this value is authentic, we have to understand the concept of correlation, or positive correlation or the negative correlation. So in this one you can see the points are like close to each other, and there's a line of best fit, and all the points are they're close to that line. So we can say it has a strong positive correlation. If we draw a line over here, we will say in this line we will see a strong negative correlation. Now the value of the correlation, it varies from -1 to +1. If there's if all the points are on the straight line and the points are like this, then it will have strong positive correlation and its value will be equal to 1. If the graph is like this, all the points are on a straight line but going down, so this will have a strong negative correlation. For this one we can say the value of r is equal to 1. For this one the value of r will be equal to -1. But for this graph we can say the value of r is positive, but it's because it's a strong positive correlation, so we can say the value of r will be equal to something equal to 0.85, which means that the estimate that we have taken from this graph is 85% accurate. So this is how the correlation helps us to estimate the value of the function with respect to the independent variables. Okay, so now we will see the type of correlations. We have discussed briefly over here, but now we will discuss in detail which is the positive correlation, negative correlation, strong positive, weak positive, and no correlation. So this is how the correlation comes into play to estimate the values of the functions. Alright, so let's see the concept of correlation. So the correlation, the value of the correlation varies from -1 to +1. So I'm just gonna draw some sample scatter plots, and from those sample plots we will try to estimate the values of the correlations. So here's the first one. It's like this. This is the second one, like this. Here's the third one. That will be something like this. Here's the fourth one. And the points are more scattered than the third one. And this is the fourth one. So in this one, these are the points. So they are not, they're over here we are not sure whether the points are going up or down. Okay, so from the first one, as you can see over here, the points are close to each other, and if you draw the line of best fit, it will be of positive gradient. So when the points are close to each other and the line shows us a positive gradient, then we can say it has a strong positive correlation. So this graph, so we will write for this one as strong positive correlation. Now here, if we draw the line of best fit, you can see it is showing us a positive gradient, but in this line the points are away from each other. So it is a positive correlation, but it's a weak positive correlation. So we will write it as weak positive correlation. Now let's move to the next one. So this is the next one where the graph is going down and the points are close to the graph. So because it's a negative, it's showing us, because the graph is going down, so it's a negative gradient. The gradient of this line is a negative. So we will say it's a strong negative correlation. Over here, we can also, if we draw the line of best fit, it shows us a negative gradient, but the points are away. So for this one, it is a negative correlation, but it's a weak negative correlation. So weak negative correlation. Now in this one, we cannot decide whether the line is going, if we draw the line of best fit, whether the line will go up or down. In fact, we are not able to draw a line of best fit for this scatter plot. So for this scatter plot, we will say it has no correlation. Now ideally, the strong positive correlation is the one where all the points will lie on the line, and ideally the strong negative correlation is the one where all the points will lie on the line and the line has the negative gradient. For example, if we draw a curve over here, so if you draw the curve like if you draw the scatter plot like this, these are the points. Now if you draw a line on these points, all the points will lie on the straight line, so that it will show the strong positive correlation. Similarly, if we draw a scatter plot where all the points lie on the straight line, but that line has a negative gradient, so it's like this. So this will show strong negative correlation, this will show strong positive correlation, but for this one the value of r will be equal to 1, and for this one the value of r will be equal to -1. So this is how the concept of correlation and the correlation coefficient evolve. In this case, this r is called the correlation coefficient, and with the help of this correlation coefficient we will see how much accurate is our estimate that we have gotten from the line of best fit. Alright, so now we will discuss the concept of linear regression. So linear regression is the similar concept that we have just discussed over here, but let's discuss separately. So linear regression. So linear regression is basically, it is the use of the line of best fit to make the prediction in the data from the scatter plot. So the use of line of best fit to make predictions in the data from the scatter plot. Is called linear regression, which is the same that we have just discussed. If we have a regression, linear regression, so let me just draw a scatter plot. So let's suppose we have a scatter plot. Here's the y-axis, here we have the x-axis, and we have the scatter plot like this. If we draw the line of best fit for this scatter plot, it will be like this. Now there are some values in the x-axis, 1 2 3 4 5, and over here in the y-axis, let's suppose we have some function f of x, and 1 2 3 4, let me just write 10 20 30 40, so to make something like an identical 1 10 20 30 40. Over here we have 1 2 3 4 5. So let's suppose we want to estimate the value of the function at x equals to 3. So we just go at x equals to 3. From x equals to 3 we will go on to the graph. So we will go onto the graph over here. It will be here. Now in front of the graph we will see, we'll go onto the y-axis, and onto the y-axis we will reach over here. So this will be something equal to 32. So we'll say at x equals to 3, the function f of x is equal to 32. So this type of estimation that we do by using the line of best fit on a scatter plot is called the linear regression. This whole process is basically called the linear regression. And in this graph, this graph shows a strong positive correlation, because as you can see over here in the scatter plot, the points are almost close to the line. They are almost close to the straight line. So yeah, they show a strong positive correlation. Okay, now that was about the correlation coefficient. Now we will see the significance of the square of correlation coefficient, and that is called the coefficient of determination. So now we have to discuss the coefficient of determination. Which is represented by r square. Now by definition, basically it measures how much prediction error that we have eliminated. It tells us the percentage of the prediction error that we have eliminated. So I'll just write down the definition first and I'll explain it in detail. So it measures how much prediction error we eliminated. And let's suppose the value of r square is equal to 0.9, or let's suppose 0.65. That will be equal to 65%. So if we get the value of r square as 0.65, it means that we have eliminated 65% of the prediction error. So what basically is the prediction error? So let's suppose we draw a scatter plot. Here's the y-axis, here we have the x-axis. There's a scatter plot, and by seeing the scatter plot we have drawn a line of best fit, and by using this line of best fit we have estimated some value of y with respect to value of x. Let's suppose this is 4, this is 6. Now how much this value is accurate from this line of best fit, that tells us about the prediction error. So the prediction error will be high if the correlation coefficient has higher value. The prediction error will be less if the correlation coefficient has the lesser value, and the prediction error will be equal to 0 if the correlation coefficient is equal to either 1 or -1, which means if all the points are close to this line, the prediction error will be lesser, and if all the points are away from the line, the prediction error will be more. So this coefficient of determination tells us the measure of how much prediction error that has been eliminated. So this is the concept of correlation and coefficient of determination. So this was it for the concept part of the linear regression. Now we have to do some example questions. So let's move on to the examples. All right, so here we have the question. It says Sam measured the height and the petal length in centimeter of all the flowers in his garden. So we have been given the height and we have been given the length. So the lengths are in the y-axis, the height are in the x-axis. So we have to add these points first of all. So the points are 30 and 6. So against 30 we have 6. So against 30 we have to click 6. So it'll be here. This will be the first point. The second point is 20 and 4. So against 20 we have 4. So 20 and 4, that will be here. The next point is 15 and 2. So against 15 we have 2. Now the next one, 35, 8. So against 35 we have 8. All right. Now 10 and 1.5. So against 10 we have 1.5. So that will be somewhere here. Then the last point is 40 and 8.5. So against 40 we have 8.5. So 40 and 8.5 will be here. Okay, so this is it. Now let's check, and it's correct. Now in the next part it says, what is the description of the relationship between the height and the petal length for Sam's flower? So as you can see over here, if you draw a line of best fit, all the points will be somehow close to this line, and this line has a positive gradient. So this line shows a strong positive correlation. Okay, so let's see. Positive association, negative association, no association. So in this one we are not concerned about strong or weak, so we just say it's a positive association, and let's check, and that's right. It means if the height of the petal increases, the length of the petal will also increase. Now, which statement is the most accurate interpretation of the association? So more height, more length. So taller flowers tended to have shorter petals, taller flowers tended to have longer petals. I think it's B. So let's check, and that's right. So the taller flowers have longer petals because the lengths are increasing with the increase in the height. All right, so let's do this one. In this data, it says data was recorded on the age of drivers and the number of car accidents per 100 drivers in the year 2009. The data is shown in the scatter plot. Okay, so seem to be a negative association. So what is the best description of the relationship between the age and the number of car accidents? So age is in the x-axis and the car accidents are in the y-axis. So it's showing a negative association because as the age increases, the car accidents decrease. So it's negative association, and that's right. Okay, which statement is the most accurate interpretation of the association? So the older drivers tend to have fewer accidents. That's true. The older drivers tend to have more accidents. False. There was no clear relationship between age and the number of accidents. That's also wrong. So it's A. The older drivers tend to have fewer accidents. All right, now let's see this one. It says shoe sizes and test scores. Dexter's class recorded data on the test grades and the shoe sizes of students in the class. The data is shown in the scatter plot. So over here we have this data, and what is the best description of the relationship between the shoe size and the test score? So over here we can see that there's no positive correlation, there is no negative correlation. It's all like it's scattered all over the place. So we will say in this data we cannot see any association. So I'll just say it has no association, because we are unable to see the trend of the data, whether it's going up or coming down. So it has no association, and that's right. Now the last one, it says which statement is most accurate interpretation of the association? Well, it's not clear because there is no association, so we cannot predict anything about the data. So yeah, that's right. So this is how we can solve the questions for the positive association, negative associations, stuff like that. All right, now that's very interesting question, and that we have just discussed the concept of correlation coefficient. It is related to that concept. So in this question it says match the correlation coefficients with the scatter plot shown below. So we have some of the scatter plots, and we have been given some of the correlation coefficients. Now, as I've told you that the correlation coefficient varies from -1 to +1. So -1 to +1. If it shows a strong positive correlation, then the correlation coefficient will be equal to 1. If it shows strong negative correlation, then the correlation coefficient will be equal to -1. Now let's see the scatter plots and check which one is what. So scatter plot A. So in the scatter plot A, you can see, if you draw a line of best fit, all the points are close to this line of best fit. So it has a strong positive correlation. In C, it shows a strong negative correlation. In B, it shows a positive correlation, but it's weaker than A. So A is positive, B is positive, C is negative, and D is somehow negative but weak. So it's weak negative. So C is strong negative, D is weak negative. A is strong positive, B is weak positive. So let's check the answers. Okay, so we have to match them. So A is strong positive. So this is strong positive. This will come in front of A. B has weak positive. So this is weak positive. Why is it weak positive? Because it is not close enough to 1 as compared to scatter plot A. So the value of the scatter plot is 0.87. That is more close to 1. But 0.73, it is not much close to 1. Now scatter plot C, it has a negative weak correlation. Oh, sorry, it has a negative strong correlation. So I'll just shift over here. And scatter plot D has weak negative correlation. Now I'll check the answers, and they are all correct. So if a number is positive and it is close to 1, it has strong positive correlation. If the correlation coefficient is it is positive but it's not close to 1, it will have positive correlation, but it will be weak positive correlation. Same goes for the negative correlations. So yeah, this is it for this topic of linear regression. So I hope you got it and understood the concept that I have taught you. Now, thank you so much for watching the video.